so this is our honors chemistry lesson video for section 12.2, and this is part 2. So in part 1, we learned how to do mole ratio. Until you understand mole ratio, you don't need to watch this part of the video yet. You have to understand mole ratio first, so go back and watch part 1 again if you need to. Alright, so now we're going to skip into a real stoichiometry problem that involves more than just moles. And so there's 3 steps that you're going to follow. So step 1 is going to be convert to moles. Now, of course, if you get lucky and start with moles, you can skip that step. Step 2 is what we learned from the previous video, and that is the mole ratio. And remember, you make the mole ratio by using the coefficients of the reaction. And then step 3 is to convert to unit asked for. Now, again, because sometimes I might ask for moles, you may be able to skip step 3. So sometimes you can skip steps. It just depends on what you start with and what I ask for. Now, how do you do step 1 and step 3? Well, step 1 and step 3 come from the conversion factors that we learned all the way back in chapter 10. So to convert to moles or to convert to unit asked for, you're going to either use 1 mole equals 6.02 times 10 to the 23 representative particles. And remember, we use this one for atoms, molecules, or ions. You might use 1 mole equals molar mass. We use that if we're talking about grams. Or you might use 1 mole equals 22.4 liters. We use that if it talks about liters or volume. Okay, so step 1, we would pick one of these to get to moles. Step 2, we'll use mole ratio using coefficients. And then step 3, to convert to the unit I asked for, we'll pick one of these again. But again, sometimes we can skip steps, so don't always assume you're going to do all 3. So this question, it says, how many liters of acetylene gas, which is C2H2, so I'm going to put a question mark and liters up there, so I know that's what I'm trying to get to, at STP are produced by adding water to 5 grams of CaC2. So what I want you to notice is they didn't ask me about water. They didn't ask me about calcium hydroxide. So if they don't ask me about either of those, then I don't need to pay attention to them. What I'm trying to figure out is if I start with 5 grams of calcium carbide, how many liters of acetylene gas am I going to get? Alright, so once you know where you're starting and where you're going, you're ready to start the possibly 3-step process. So I always start with what I'm given. So I'm given 5 grams of calcium carbide. So the first step is I need to convert to moles because I was given grams. So I go down here. Which one would I use to convert to moles? Well, since I have grams, I'm going to use molar mass. Alright, so that's how you pick the first step. Alright, so for molar mass, of course, I add up Ca and 2 Cs. So Ca is 40, C is 12 times 2. I'm just pulling the masses from the periodic table. That's the bottom number on the periodic table. And so when I add it up for CaCl2, I get 64 grams per mole. So, because grams is on top, I'm going to put the 64 grams on bottom and the 1 mole on top. Remember, whenever you add up molar mass, that's always the mass of 1 mole. It doesn't matter if the formula has a coefficient. We don't use coefficients in step 1. We only use coefficients in step 2. Alright, so see, now I've gotten it to moles, so I move on to step 2. Step 2 says mole ratio. Step 2 is how we get from one substance to another in a reaction. Okay, so unless I'm sticking with the same substance, I'm going to have to use mole ratio at some point. So remember, the mole ratio is just the coefficients, which in these cases are both 1. However, which one goes on bottom? Well, remember, now that we're into stoichiometry, the golden rule doesn't just involve the unit. It involves the unit and the substance. So since I have moles of calcium carbide on top, I'm going to put the moles of calcium carbide on bottom. Well, how many? Well, since it has a coefficient of 1, I'm going to put 1 mole calcium carbide on bottom. Well, what does that make? Well, the reaction tells me that will make 1 mole of acetylene gas. And to see if this had been a 4, I would have put 4 moles on top. So see, moles of calcium carbide go away, and so see, now you can notice that I have switched substances. I no longer have CaC2 anymore. I have C2H2 now. Okay, so I did my mole ratio and I switched substances. So step 3 is to convert to the unit I asked for. Well, in this case, I asked for liters. So if you look, I need to pick one. Well, I use 22.4 liters when I'm trying to go to liters at STP. So I got to figure out what part goes on bottom. Well, I have the 1 mole of C2H2 on top. So that means I want the mole to go on bottom and the 22.4 liters to go on top. So see, the moles cancel. And so then to solve these, just like we've been doing all year, you multiply the top, so 5 times 22.4, and divide by the bottom, so divided by 64. And so when I did that, I got 1.75. My unit is liters. My substance is C2H2. So again, don't forget, number, unit, substance. All right, now the first time you see one of these, it can be slightly overwhelming. Okay, but again, they just take practice. Okay, that's what chemistry is all about. The more you'll practice, the easier it comes, and then it doesn't seem like such a hassle to do all this stuff. And plus, the more you practice, you'll find that you can kind of do some steps in your head or just in your calculator, and that saves some time too. All right, so let's look at another one together. So we'll look at this one right here. So it says how many molecules of oxygen, so I'm going to put a question mark and molecules above oxygen, so I know that's what I'm going to, are produced by the decomposition of 6.54 grams of potassium chlorate. So here you have to be careful. Which one is potassium chlorate? It makes a difference. Well, this is potassium chloride. Chlorate is ClO3. Okay, so we're going to start with 6.54 grams of potassium chlorate. So we're going to go from here to here. We're not worried about potassium chloride at all. It didn't give me a number. It didn't ask me about it. So we just pretend like it's not there. All right, so remember, I'm going to use my steps, but let me start with what I know first. So I know I have 6.54 grams of KClO3. Oh, that's a 3, by the way. All right, so my first step is to convert to moles. Well, I was given grams, so I need to use molar mass to convert to moles. So I'm going to add up the molar mass of KClO3. So K is about 39. Cl is about 35, oxygen is about 16 times 3. So when I do that, I get 122 grams per mole. So since the grams is on top, I'm going to put the 122 grams on bottom, and then molar mass always equals 1 mole. So the 1 mole will go on top. So stoichiometry is all about following the golden rule, as is so many of the things we do in here. So step 2 is mole ratio. This is where I use the coefficients. So I can see that 2 moles of potassium chlorate makes 3 moles of oxygen. So I got to figure out which part goes on bottom. Well, I have moles of potassium chlorate on top, so I want moles of potassium chlorate on bottom. Well, how many moles? Well, look at my reaction. This is where I use coefficients. So it's 2 moles of potassium chlorate. I'm trying to get to oxygen. That will make 3 moles of oxygen. See, this is where that mole ratio comes into play. So my moles of potassium chlorate cancel, and so if you notice, now I've switched over to oxygen. So potassium chlorate is gone. I'm not focusing on that anymore. So then I move on to step 3, convert to unit asked for. Well, I asked for molecules. So I need another step. So I pull one of these. So which one helps me get to molecules? Avogadro's number, 6.02. So since I have the mole of oxygen on top, I'm going to put the 1 mole on bottom, and then the 6.02 molecules on top. So my moles cancel, and so then I multiply the top, so 6.54 times 3 times 6.02 times 10 to the 23, and divide by the bottom. So I'm going to divide by 122 and divide by 2. And when you do all that, you should get about 4.84 times 10 to the 22 molecules of oxygen. All right, and so you may want to just try to make sure you put this in the calculator and get this answer. Okay, it really is terrible if you set up all of these steps and do it all correctly, but then you put it in the calculator wrong. Okay, so just make sure you can get it into the calculator correctly. All right, so maybe pause it. You try the bottom one. The bottom one does have a little extra part to it because you have to write the reaction yourself. But just pause it, try it, or at least wait until I give you the reaction and then pause it and try the stoichiometry part. So it says propane, which is C3H8, is a common fuel used for cooking and home heating. What mass of O2 is consumed in the combustion of 1 gram of propane? All right, so because this is so low, I'm actually going to erase this one and put my answer up here just so it's a little more visible for y'all. Sometimes I get worried you can't see all the way at the bottom of the board. And so. All right, so the first step is, notice they didn't give me a balanced equation. I have to write it myself for this one. Okay, so it tells me we're starting with propane. And it tells me that we are doing a combustion reaction. So I know from earlier in chapter 11 that a combustion reaction is when something burns an oxygen, and if it's a hydrocarbon, which this is, it's going to make carbon dioxide and water. Okay, if you did not realize that, you need to go back to chapter 11 and watch the 11.2 videos because that's when I cover combustion. All right, so I need to balance because I'm going to have to use the mole ratio. So if I don't have the coefficients, I can't do a mole ratio. So I have 3 carbons here, 1 here, so I'm going to put a 3. I have 8 hydrogens here and only 2 here, so I'm going to put a 4. So 4 times 2 is 8. Last is oxygen. I have 2 right here. I have 3 times 2, which is 6 here, and 4 more, which is 10. Okay, so see, I have 3 times 2, which is 6, plus 4 more, which is 10. So what times 2 makes 10? A 5. So see, now I have my balanced equation. Okay, so remember, I'm doing this question, but I'm just going to do it up here. So we don't need to look at this at all. All right, so now let's figure out what they're asking me. So they said, what mass of O2, so in other words, I'm looking for grams of O2, is consumed in the combustion of 1 gram of propane. So in other words, I'm going from here to here. So I'm staying on the same side of the arrow, and it works exactly the way as when we go to the other side of the arrow. Okay, so I start with what I know. So I have 1 gram of propane. So my first step is to convert to moles. Well, since they gave me grams, I need to use the molar mass to get to moles. So I add up C3H8, so C is 12 on the periodic table times 3. H is 1 times 8, so when I add that up, I got about 44 grams per mole. So since grams is on top, my 44 grams goes on bottom, and my 1 mole goes on top. So see, grams cancel. So now I keep going. So step 2 is mole ratio. This is where I'm going to use the coefficients. So if you don't balance the equation correctly, you're going to kind of miss the mole ratio. Okay, so I know moles of C3H8 needs to go on bottom because I'm following the golden rule. How many? Well, it has a coefficient of an understood 1. We're trying to get to oxygen, which has a coefficient of 5. So that's going to make 5 moles of oxygen. Well, it's not going to make, that's going to use 5 moles of oxygen since they're both reactants. All right, so see, now I've officially switched over to oxygen. So we're not talking about propane anymore. So then it says step 3 is convert to unit asked for. Well, in this case, it asks for how many grams of oxygen. So I do my last step. I'm going to have to use molar mass again. And this is where it gets a little tricky if you have to use molar mass twice. Over here, because I was talking about C3H8, I added up the molar mass of C3H8. But if you look over here, now we have moved on to O2, to oxygen. So now that I need to do molar mass, I'm going to add it up for O2. Because see, I've canceled out all my C3H8. So oxygen's 16 on the periodic table, or the mass is, and times 2 is 32. So 32 grams in 1 mole. Well, because I have the mole on top, I'm going to put the 1 mole on bottom and the 32 grams on top. Remember, that's how you determine what goes in the numerator and the denominator. You just follow the golden rule. All right, so I made it to grams of oxygen, which is what it asked. That's how I know I can stop. And so then I just multiply. So 1 times 5 times 32 divided by 44. And so what I got for this one was 3.64 grams of O2. So hopefully you got that one right. Like I said, for this one, it's tricky because if you didn't get the reaction right, then you're probably going to miss the stoichiometry part. So this is why, again, I keep saying that you've got to learn the skills as we go over them, because if you haven't noticed, it just keeps building and building. So hopefully after you've seen me do a couple now, you're feeling a little more confident. Okay, so if you haven't tried one on your own, maybe try this one real quick, pause it. I'll assume you've done that. So it says how many molecules of oxygen, so here I'm looking for molecules, are required to burn 3.86 liters of carbon monoxide. So again, you got to make sure you pick the right one. This one's carbon monoxide, this one's carbon dioxide. So we have 3.86 liters. So we're going from here to here. All right, so I start with what I know. So I have 3.86 liters of carbon monoxide. And so the first step is to convert to moles. Since I have liters, I'm going to use the 22.4. So I know that since I have liters of carbon monoxide on top, I'm going to put the 22.4 liters of carbon monoxide on bottom and the 1 mole on top, because I want those liters to cancel. So then step 2 is mole ratio. So I'm going to use my coefficients. So I can see I need moles of CO on bottom. Well, how many? Well, it has a coefficient of 2. So it's 2 moles of CO. We're trying to get to oxygen, which has an understood coefficient of 1, so that equals 1 mole of oxygen. So for every 2 moles of carbon monoxide, I need 1 mole of oxygen. And then step 3 says convert to unit asked for. Well, it asked me for molecules. So I go down here, which one do I use for molecules? I use Avogadro's number, 6.02. But which part goes on bottom? Well, since I have moles of oxygen on top, I want the 1 mole on bottom. Because see, then it cancels. And then my 6.02 molecules goes on top. So, as always, I multiply the top, so 3.86 times Avogadro's number, and divide by the bottom. So I divide by the 22.4 and the 2. And so once I do that, I ended up getting 5.19 times 10 to the 22 molecules of oxygen. Again, if you get lost on what your unit and substance are, it'll be what you end with right here. Alright, so see, after you try a couple of them, stoichiometry is super fun. I love stoichiometry. I even liked it in high school because I feel like it's super logical, just following the steps. Alright, so even if you missed that one and you're not loving stoichiometry yet, okay, maybe pause it, try this next one, because whether you love it or not, it's going to be on the test. Try this next one, and then I'll assume you've done that. Let's look at it together. So it says how many grams of phosphorus trihydride, so I'm looking for grams of phosphorus trihydride, are formed when 0.42 liters of hydrogen reacts with phosphorus. Now notice all it says is that it reacts with phosphorus. Like it doesn't give me a number or anything like that for phosphorus. So we're not worried about phosphorus. So we're just going from here to here. Alright, so as always, I just start with what I know. So I have 0.42 liters of hydrogen, which is H2. So my first step is convert to moles. So I use molar mass to convert to moles. Well, hydrogen's 1 times 2 is 2 grams per mole. Sorry, we're starting with liters. We're not even starting with grams. Sorry about that. Okay, just kidding. We're going 2 grams. So we're starting with liters. I got to convert to moles. So I look over here. I use 22.4 liters to get to moles. So because my liters is on top, I put my 22.4 liters on bottom. And that, of course, equals 1 mole. All right, so my liters of hydrogen cancel. Sorry about that. Not using molar mass for step 1. All right, so then we move on to step 2. It's mole ratio using the coefficients. So I can see that 6 moles of hydrogen is going to make 4 moles of phosphorus trihydride. How do I know what I want on bottom? I follow the golden rule. So I want moles of hydrogen on bottom. How many? Well, it has a coefficient of 6, so I want 6 moles of hydrogen on bottom. That is going to make 4 moles of phosphorus trihydrate. So my moles of hydrogen cancel, and so see, now I've officially switched over to phosphorus trihydrate. So the hydrogen's gone, and now we're at pH 3. So last step is to convert to unit asked for. So this is where I needed grams. So I asked for grams, so that means you're going to use molar mass. So you're going to add up pH 3 off the periodic table. So P is about 31, H is 1 times 3, so we get about 34 grams per mole. But because the mole is on top, I'm going to put the 1 mole on bottom and the 34 grams on top. So then my moles of pH3 cancel, and then I'm ready to solve. So I multiply the top and divide by the bottom. And so for that, I ended up getting 0.425 grams of pH3. All right, and so there we go. Now, in this lesson video, you may notice like we're not ever skipping any steps. That's because I want to get you really strong in being able to do all 3. So that way when you get to one where you can actually skip steps, it's a lot easier. Okay, but we will eventually do some where you can skip steps, and on your practice sheets and things like that, you can skip steps. So don't think like on the test, all of them are going to be all 3 steps. I'm just trying to get you really good at being able to do all 3. Okay, so let's knock out that section assessment, because this section's kind of long. Well, the next section's even longer. I don't even know what I'm talking about right now. All right, so there's our answers. And so last, our section assessment. At least this one's pretty easy. It's pretty short, just one question. Well, it's kind of like a 2-in-1. So I'm going to do one part, and then I'm going to let you try one part. So it says the combustion of acetylene gas is represented by the following equation. How many grams of carbon dioxide and grams of H2O are produced when 52 grams of C2H2 burns in oxygen? So this is why I say it's like a 2-for-1. So we need to figure out how many grams of carbon dioxide, and we need to figure out how many grams of water. Okay, so what I'm going to do is I'll do the first part. I'll figure out carbon dioxide, and then you pause it, and you figure out how much water, and then we'll have both parts. Okay, so I'm going to start with what I know, so that's 52 grams of C2H2. Now remember, I'm going to go to grams of CO2. I'm not going to worry about water. I'm going to let you try water in just a second. All right, so our first step is convert to moles. Well, since I have grams, and this time I really do, I'm going to use molar mass. So I add up C2H2 on the periodic table, so C is 12 times 2, hydrogen's 1 times 2, and so once I do that, I get about 26 grams per mole. So since grams is on top, I'm going to put my 26 grams on bottom and my 1 mole on top. So my grams cancel. Second step is mole ratio. So this is where I'm going to use the coefficient. So I can see that 2 moles of acetylene gas makes 4 moles of carbon dioxide. So because I have C2H2 on top, I'm going to put the 2 moles of acetylene on bottom and the 4 moles of carbon dioxide on top. So my moles of acetylene's gone. So see, I've officially switched over from acetylene to carbon dioxide. So our third step is to convert to unit asked for. Well, since I didn't ask for moles, we have to do that step. So it asks how many grams we're going to make. So again, I need to use molar mass, but this time I'm using the molar mass of CO2. So I add that up off the periodic table. So C is 12, O is 16 times 2, so that gives me 44 grams per mole. So following the golden rule, I'm going to put the 1 mole on bottom and the 44 grams on top. So my moles cancel. So then I just multiply the top, divide by the bottom, and so for this one, I got about 176 grams of CO2. So now, pause the video, and I want you to try to go from here and see if you can figure out how much water. And then, of course, that would give us our total, the carbon dioxide and the water. All right, so I'll assume you've paused it, and let's look at it together. So again, I'm still starting with 52 grams of acetylene, C2H2. So step 1 is convert to moles. So I'm going to use molar mass. But if you notice, y'all, we just did that part. We just converted to moles of acetylene right here. So I can just pull this step down. 26 grams of acetylene is 1 mole. So my grams cancel. Step 2 is mole ratio using coefficients. Now this is where you can't copy mine, because see, I was going to carbon dioxide. You are going to water. So 2 moles of acetylene makes 2 moles of water. Which one do I put on bottom? Well, since I had acetylene right here, I'm going to put the 2 moles of acetylene on bottom, and that's going to make 2 moles of water. All right, last step is this to convert to unit ask for? Well, it asked me for grams of water, so that means I need to do molar mass again, but this time I'm going to do the molar mass of water. So hydrogen is 1 times 2, oxygen is 16, so I get 18 grams per mole. So because mole is on top, I'm going to put the 1 mole on bottom, and that equals 18 grams. So my moles cancel. So then I just multiply across the top and divide across the bottom. And so when I do that, I get 36 grams of H2O. So this is how much carbon dioxide and water I'm going to get if I burn 52 grams of acetylene. Alright, so like I said, for stoichiometry, even though I just showed you examples where we use all 3 steps every time, that's not necessarily the way it is. I just want you to get really strong at doing all 3 steps, so that way if you can skip some, it's just that much easier. And see, stoichiometry isn't so bad. Hopefully you're ending up liking it as much as I do.